So I'm the originator of the project, and that's why I'm here, to tell you some of the basic ideas about UK GEOS. In fact, I spent some of my early educational life here in Cheshire, so I'm partly a Cheshire boy. I went to school in Macclesfield and I lived in Gawsworth, and when I was a kid, I saw that wonderful thing that we can see out the window. Sort of the curtains are shut, but that wonderful structure, I saw it every day when I went to school. And I'm sure it had an influence on me. I'm sure one of the reasons why I decided to be a scientist was because I could see that, and it made a difference to me. So it really is a personal interest for me. So science is about big kit. Big science, big advances in science are about big infrastructure, and that's what we're talking about here. So David mentioned, and the film mentioned, the idea of measuring, of understanding, and it's really part of a concept called a geological macroscope. And we know what microscopes are, looking at very small things with a specialized piece of equipment. A macroscope is looking at very large things with lots of sensors. So the idea of a macroscope is building distributed sensors for looking at very large things. We have macroscopes for the atmosphere. It's called our meteorological system. It feeds into the Met Office, for example, and other databases and computers, and turns into a weather forecast. We have one for the oceans. So, for example, the fact that we know that there are a lot of plastics in the oceans, the fact that we know that the oceans are changing, is because we have a macroscope. But we don't really have a macroscope for the subsurface. And the subsurface is the environment, just as much as what we can see above the ground. It is the environment, and we have to look after it if we're going to use it. So this is not a flash in the pan. This is the BGS strategy published in 2014, which I coordinated. And I remember writing a little paragraph on the right in the second page there about energy test beds. And one of the thrusts of the strategy was instrumenting the Earth. Can we build a geological macroscope, put sensors in the Earth and understand the Earth better? And I remember writing that paragraph and thinking, can we do it? And we are there, we're nearly there. So that part is certainly a part of the science for our institution. And developing energy test beds was always part of the strategy, the science strategy of the BGS. And it really encompasses or encapsulates our direction of travel in the British Geological Survey. We're looking at observatories in developing countries, for example, catchment observatories to help developing countries manage their underground, manage their groundwater, manage pollution. We're looking at observatories that look at magma in Iceland, so observatories that help us understand how magma flows under the ground so that we might use it for geothermal, or maybe even be able to control volcanism. So this is really, this site, UK GEOS, is actually an encapsulation of BGS's ambitions for the future. And you might say, why is it that we're pushing so hard now? It's because three things have come together to make this possible. The technology exists, the sensors that we need that are very much able to deal with deep subsurface pressures and temperatures and water. Those sensors are available. They're getting cheaper and cheaper all the time, things that you can put in the subsurface. The technology exists in the sense of visualization. So BGS has been a pioneer of visualizing the underground. You saw some of it in the film. We're able to use software that helps us to dive under the ground and fly around, seeing these layers of rock. We can do that. We couldn't do it, a decade ago very well. And of course, perhaps the biggest thing is computing power. So that computing power to be able to deal with a vast amount of data coming in from the subsurface to make those sorts of predictions and forecasts like the Met Office make, the atmosphere, that technology exists now, and we are making use of it. So those are the three things that have come together. And it's really about showing that decarbonisation, if we want to do it, is very much a problem of the subsurface. The subsurface can help us to decarbonise and to understand environmental change. I've got some little icons here in my slide here. If we want to deal with carbon dioxide that we're producing through industrial and power production, can we develop carbon capture and storage? You may have heard of the idea of putting CO2 in the subsurface. That has some scientific questions around it. This facility will be about understanding and taking those science questions apart and answering them. In the environment, compressed air energy storage is an interesting solution to the fact that we sometimes overproduce energy, and we need to store it and use it when we don't have enough. Hydrogen storage, in this area, it could be very interesting to develop a hydrogen economy. We have the ability to store hydrogen, we have hydrogen producers, we could have an alternative vector for energy using hydrogen, but it will need the subsurface because you need to store hydrogen in appropriate rocks if you're going to do it on any large scale. And of course, energy. John Midgley mentioned in the film, geothermal, if we could unlock it, could be a really neat way of decarbonising heat, because most of us use gas heating our houses. Could we use heat from the earth? So the test site in Scotland, in Glasgow, is looking directly at mine water heating. But here in Cheshire, there are some hot waters under Crewe, for example. We don't really know why, but there are parts of Cheshire which have hot water. Can we use geothermal? And hydrocarbons. So, for example, shale gas, it's an issue in this area. Can we understand the issues surrounding shale gas, the extraction and production of shale gas? So it's about understanding those areas for decarbonisation and environmental change. So how did we decide to choose these sites? We've alighted on 2 sites, one in Glasgow, one in Cheshire. Well, what do we need from a site? What do we actually physically need? Well, we need lots of data. We've obviously collected data, but we needed data to begin with. And we have a lot of data in this area. We know a lot about the geology of the west of Cheshire. We needed a site or sites with different geological types because we want to do several things. You probably noticed that we're talking about different things. This is an infrastructure or a piece of kit to do lots of different things, just as that machine out there, outside past the curtains, does lots of different things in the telescopy area. And we also needed a place that was representative of the UK environment. You might say, why didn't you go to a pristine environment where there's nothing, like the north of Scotland? Well, the answer is that wouldn't solve our problems because we live on a crowded island and we need to be able to do the science that's relevant to places which have a lot of activity in the surface and subsurface. So let's just look at Glasgow. So Glasgow is really interesting. It's a major industrial city that overlays, it's on the top of coal mines, and that's not something that just happened. Lots of our big cities sit on coal mines because that's where our wealth came from in the Industrial Revolution. Lots of cities are like this in Germany and in the United States as well. But one of the useful things about those coal mines is essentially they are full of warm water. Not very warm, but warm enough, if we deal with it properly in engineering terms, that could provide low energy, low carbon heat. So the questions are, is there enough heat down there? Is there enough for houses and businesses? We don't know at the moment. What's the most efficient way of getting it out? And how fast is the heat replenished? So if you take it out, then obviously you're pulling it out of the ground. Does it come back quickly enough to make it a sustainable business? That's a really important science question. It's quite hard to answer. So that's what we'll be looking at. We'll do science to look at that. As Michelle said in the film, it's about de-risking. Why is Cheshire so important for geology? Why is this site in Cheshire that we've chosen? You can see an image of the site area. First of all, we have the Sherwood Sandstone Group, which sits underneath that. If you're interested in knowing where that is, it's basically the Frodsham Hill group with those lovely hills that you can walk on. Those sandstones are essentially slightly higher, but those are essentially the same sandstones, and they sit underneath the site. There's also a barrier. So there's a cap rock layer underneath that sandstone layer. And underneath that, there are layers which, like the coal measures and the Millstone Grit series, contain energy or storage possibilities. For example, for carbon dioxide storage. So this combination of an area that you want to protect, you don't want an aquifer to contain anything that you don't want to use, the barrier, which is the way that you can separate a protection zone from a source or a disposal zone, That technically is a really valuable combination for us to work with, and that's what we've got in West Cheshire. An example, just a simple example, and remember that we're looking at many different technologies and science questions in this area. When those lovely wind turbines are turning on in marshes, sometimes they're overproducing. Sometimes we have more electricity than we need. Can we take that and can we store it? Not necessarily in that area, but can we look at a technology whereby we could compress air by that turning turbine, get the air down under the ground, compress it inside the sandstone, and then release it when we need the energy, so when we need the electricity. But can it be done? Well, there's some work to be done. It's not necessarily that we could prove that it could be done here, that it would be done here on a large scale. It's just that we need to do the science to see if it can be done. There are research questions that are quite fundamental. So the schedule is, we are working on planning applications in October. There's a 16-week statutory consultation. Again, if you want to know more about this, you can talk to Jeff Baxter, who's the project manager here. If approved, we'd start construction 4 months later. Construction's complete within a year. Decommissioning at the end of life, that means the boreholes that we're going to drill, sealing them up and making them completely sealed so that they, nothing will happen. That is something that we will do as well. And we'll remediate the land after use. One thing that kind of makes me slightly disappointed is that, as I said, when I was a young lad growing up in Macclesfield in Goresworth, seeing this wonderful thing outside, we're not going to have anything like that, unfortunately. It's not going to look magnificent, great big wonderful dish. It's not going to look like much at all. It's just going to be a few boreholes that hardly are visible at all. But we'll be collecting lots of data, so it won't look particularly grand. Perhaps that's why we're here. So data and science, one of the biggest ideas that we had right from the beginning was that everything we produce will be completely available as much as possible in real time. We're already doing this. The British Geological Survey already monitors and makes available data in all sorts of forms. But we will do this at the site. So this information will be unique. There will be no other corpus of information of this type anywhere else in the world. So for local planners, local people interested in the use of the subsurface in Cheshire, you will have the best database in the world to look at the way that the subsurface reacts to changes. And it will be available to everyone, for the public, for scientists, for industry. And again, not forgetting when I was a kid growing up, interested in science, this will be available to local science students. And we will be there to help them work with it as well. So there's some seismicity data, that's earthquake data, and groundwater quality data. This is actually online right now, not in this area, but elsewhere. And I see this as very much part of Cheshire's clean growth strategy. The energy, the science, the industry, the innovation that surrounds this area. Here's Daresbury. It's an energy innovation district. We have the energy and clean growth strategy from the LEP. It's very much part of that. They've mentioned our idea. The Cheshire Energy Hub. It's very much part of that. We're looking at how you decarbonize. We're looking at energy. We're providing science, answering the questions that come up that will help to improve the force of West Cheshire's fantastic science offering, science and innovation offering. We'll be offering learning opportunities as well. So we'd expect to work with the local universities. We're already working in detail with the University of Chester, but we would expect to provide access to apprentices, to PhD students, to master's students, to people who are interested in subsurface engineering. Britain already has a fantastic expertise in subsurface engineering from the North Sea, for example. Our petroleum engineering, is the best in the world. But what we're looking at here is decarbonisation subsurface engineering. It's slightly different. I mean, we're dealing with often putting things under the ground rather than taking them out. But this is a really important part, and I'm sure Zoe will mention this. Underpinning innovation for the energy cluster. So we know that energy clusters are important. I was yesterday in Ironbridge on a field trip. I don't know if you've ever been there. There's a fantastic bridge that was built during the Industrial Revolution, the first large iron structure. The reason why it's there is because there are three things there geologically. There's coal, there's iron ore, and there's limestone. They're within about 2 miles. So you could do it even in the 18th century. You could get all that stuff together and build an iron bridge. Clusters still matter. Geography still matters. And Cheshire has an amazing cluster with the power and intellectual energy, the experience, the people that live here, the engineering expertise, the science expertise in this area is second to none. So we'll put that to force as well. So just wrapping up, I sense I probably talked too much. I haven't, okay. So the first geological macroscope is what we're looking at here. This will be the first of many. As I said, our ambitions is to go to Iceland, to go to Southeast Asia, to continue this development of subsurface observation. But we're going to do this here, and it's going to be part of a larger understanding of the subsurface. As I said, the underground is the environment too. Don't forget that. We'll listen to the underground. We'll collect data. We'll provide data for everyone for free. Everything is going to be open. And the field site will strengthen low carbon science, innovation, education and training, infrastructure and industry. And it's part of a cluster. We can really strengthen your cluster here in Cheshire with this piece of science, this piece of infrastructure. I think that's it.